All right, good afternoon. I'm Adam with Foster's Pumps. Welcome, everybody. Today we're going to start out with our first class, and we're going to be learning about pump panels. And pump panels are specific to our industry in the sense that we run a lot of pumps on these in three-phase applications primarily. There are applications where we run these panels in single phase. We won't be covering that today. That'll be in a different training. But today we wanted to focus on the pump panels, their design, what they're used for, and why we use them in the pump industry. So a pump panel is basically a series of electronic components that will run a pump. And let's just get into it. So in a pump panel, there are 5 major components. We have number 1, the disconnect, and it's operated right here through the door with the handle. Number 2 is the fuses, the fuse clips. Number 3 is the magnetic starter. It's got a contactor in here. 4 would be the overload relay. And last but not least, 5 is the selector switches, push buttons, and control circuitry. So, starting at the top, the disconnect. Well, what is it for? So, disconnect does a few things. One, it provides an emergency source of disconnect for power. So, it turns on. Obviously, there's a door on this panel usually. So, on is on. That's sending power through if power is here. And if there were an emergency, you could shut this off, and it would kill the power going to the motor, to the starter, to the whole box. And it would also, you could lock it out to service it. So basically for service purposes, for emergency disconnect, for basically any type of service work, you can use that disconnect. It allows us to shut it off, to work on it, to service it, and lock it out so that we can be safe. Lockouts will be in another video as well. So moving on, we have the fuse clips. This is a 3-phase pump panel, so there are 3 fuse clips. We use Allen Bradley here at Foster's Pumps. We believe it to be the highest of quality in the pump panel realm. So this one has a really unique fuse clip in that it actually, you can bolt your fuses in. So you slide them into these little gaps here, and then you can bolt them in with a flat or slotted screwdriver. That's good because we see in the Square D applications and the Siemens applications, we find that over time, thermal expansion, getting hot, getting cold, overheating, running long times, short cycling can cause those fuse clips to expand and contract. That's thermal expansion and contraction. And what happens over time is it does that enough where they get loose, and then you start seeing burn back on your wires here and burn back into your disconnect. And you start blowing fuses prematurely. So having this bolt-in fuse is really nice, the bolt-in fuse clip. However, you got to be careful because I've had our guys, and even I have once or twice, broken this screw off when you over tighten it. So be careful. We've even had some of our guys in the past take this out and put a little bit of no-lax on it. It's like a conductive lubricant. Usually when you use like dissimilar metals like copper to aluminum connections, which would most likely in this case be one. With the fuses, and this is aluminum. So moving on, the fuses, what do they do? Well, there's a couple things that a fuse does. It provides protection from overcurrent, extreme overcurrent. It provides protection from a short circuit if something shorts out. And last but not least, lock rotor amp. So if the motor goes to start and it's locked up, connected to a pump in our industry, we find that the pump got something in it, and it will blow a fuse on 1 line or 2 lines, or sometimes even 3. I've seen it, but usually 1 or 2. So how do we troubleshoot the fuse clip, the fuses? Well, you take an ohm meter, put it on ohms, and you go top to bottom with power off, obviously, and you can ohm out. If it beeps, ohms out, that's a good fuse. If it doesn't, it's a bad fuse. Pretty simple. Moving on into the starter, the magnetic starter or contactor. This is a 3-pole switch, basically, is how I like to say it. Now, I'm sure someone will challenge me on that, but it's basically a switch that is driven by an electronic coil, a magnetic coil. So When this coil gets the power it's designed for, it creates a magnetic field that will close these contacts, therefore sending this three-phase power through and down and out to the motor. And that's basically all this thing does. It has contacts in here. Contacts can go bad, so when you're troubleshooting these, it's nice to have a window, a little inspection. These NEMA rated pump panels and starters have inspections windows. You can take these covers off and see them. You get into IEC rated contactors. I don't like them for the simple reason that you can't look at them. You can't open them and see. I like to be able to see if my contacts are bad. Now, something I always teach across the board in contacts, if they're blackened, if they have like a oxide dust on them, that is not a bad contact. What I like to say is a bad contact would be pitting, and if it's starting to look like a mushroomed head, like you ever take a hammer and just beat the heck out of it and it mushrooms out, or a punch. If they start mushrooming over, or if they get bad pits in them, then they are deemed bad. Now you can take emery cloth, set it on a flat surface, and take that and flatten that out. There is silver in those, so they're very expensive, so some people like to try and flatten them out a couple times. You can take all these apart. It's a whole nother topic, but you can do that. You can also change them. One thing I've found with Allen Bradley, we don't change contact kits. Even with the pump that's short cycling, unless it's extremely undersized, the panel to the pump, to the motor, contact kits just don't go bad in Allen Bradley. Now, that's typical, not always. There's exceptions to every rule, but with Square D, with Siemens, we've had our fair share of contacts. We actually stock all the brands out here on the shelf, but we don't really stock these. We just don't have issues with them. So moving on, we do have a magnetic contactor. The starter is magnetic, and it's got a coil. So in this application, this is a 230 volt coil, 240 volt coil. So when you get two legs of 120 here, it creates 240 leg to leg. That creates a magnetic field that pulls a big chunk of metal and closes this, sends power out. So that's what the magnetic starter does. That's what turns the motor on and off. Ultimately, that's it. This one is rated for, I believe, 90 continuous amps. On 460 volt, it's good for 50 horsepower. Max amps is 90. You can see right here. So Allen Bradley, good stuff. So on 200 volt, this is rated for 25 horse, 230, 30 horse, 460, 50 horse. So just something to keep in mind. Always look at your electrical components before you install them. Very, very important. You know, you open the box up, you look at it, you install it, and you don't really think about what you're putting in, and you might create problems for yourself. So it's always good in electricity to be looking at what you're installing before you install it. Confirm, run the numbers, use a slide chart. That'll be another topic as well. So moving on, we have the overload relay. Now this is an electronic overload relay. The old Allen Bradley had heaters, and basically they were just mechanical devices that when they got hot, they would push out a little spring-loaded deal, and it would trip a switch in here. These electronic ones are just that. They're electronic. So they're really nice. On this, you can turn it anywhere, on this one, anywhere from, I believe, 20 amps to 100 amps. And you just turn the dial right here, you set it. Now what I like to do, and what we do here at Foster's Pumps, is we set it right at service factor amps. We run motors with high service factors, WEGs, for our non-clogs, and we always just have set it at service factor amps. So we take the amps times the service factor, that gives us service factor amps. That's what we set this to. Now this does have a reset right here. It has a test trip button that'll trip it when it's on. You can't do it when it's off. And it also has, I believe, the trip class is right here. Now trip class is kind of cool. They usually come to 20. They're set to 20, which is standard. But when you're working in any type of submersible pump, which we do in Foster's a lot, we always set to the manufacturer specs, which is a trip class of 10. So whenever you're putting a pump panel on a motor that's going to be submerged, whether it be a submersible sewage pump, a submersible pump, that's about it. Irrigation, big subs, small subs. Usually you go to a class 10. That's what we ask. Put your trip class to a class 10. Last but not least, you have 95 and 96. That's a closed circuit that when it trips out, it opens. So that's a closed circuit. Power is going through it to the coil. It senses high amps for the amount of time it's made to, then it'll open that circuit, and then it will kill the power to the coil. There is also, on this electronic overload, in most of them, there is a 97 and 98. And that is an open circuit that closes. So you could come on top of here, you could put a control transformer in here, 120 volt through that, and have it run a little beacon light. So when your pump trips out, your pump panel trips out, it would turn a beacon light on and you could be signaled. So that's kind of a neat feature. Last but not least here is the control circuitry. So we have a selector switch and a push button. And what it is we have one power wire that comes off leg 1 in this application, and it goes down to the HOA and jumps from one of these contacts to another. When you turn it to hand, it sends power to the push button and over here to the auxiliary contact. When you push the push button, it sends power through the push button and to the coil. And then once it engages, the auxiliary contact closes and holds it in. The other power source on this Allen Bradley is on leg 2. It goes down through 95, out 96, directly to the coil. You have to keep those two circuits separated. The way I always do it, I always tell our employees is wire your overload relay first and keep nothing else on it. So right from power through 95, out 96 to the coil. You're done with half of that. Half of your circuitry is done. The rest is the control circuitry. We will be getting into that quite deeply in possibly another video, but today was just to kind of give you an overview of what we find. Now, a couple things to troubleshoot. If I have good power, I'm going to take my ohm meter, and in about less than 5 minutes, I can diagnose this whole thing. So if first I find that good power is good coming in, I would shut my disconnect off. I'm going to ohm my fuses, top to bottom. Beep, 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 good fuses. I'm going to come over here to the starter, and I'm going to ohm out my coil. If I have any type of continuity, 99 times out of 100, that's a good coil. Now, if you're confused or if you're still not working and you have some issues, you can always take a manufactured spec'd new coil and you could ohm it and make sure. But usually when a coil burns out, it doesn't ohm out at all. It will basically OL. You won't get any beep, you won't get any number. So if the coil's good, you're going to get a number and sometimes a beep. Not necessarily nowadays. These coils have enough resistance in them where it's past 30, which is typical with a beep threshold on like the Flukes. Moving on to test the overload. This is 95 and 96 is a closed circuit, so when you go between them with your ohm meter, it's going to ohm out. Same thing over here on your selector switches. You can go from top to bottom, turn it to hand. It should ohm out. Push the push button, and it'll ohm out, top to bottom. And that's really about it. So your ohm meter really takes the whole cake when it comes to troubleshooting a pump panel. Once you have voltage specified and you know your voltage is good, then you're moving on to all of the other things, ohming them out. And we can get into diagnostics and wiring extremely well in another video, but today it was just to give you an overview on the pump panel, the components, how to quickly troubleshoot them, what they're used for. So yeah, like I said, Foster's here, we do only Allen Bradley on our pump panels. We find them to be state of the art, the best stuff. I'm sure in the comments we might get some people disagreeing, and that's great. That's what it's all about. All right, you all have a blessed day, and we will see you on the flip.